Hello and welcome to lectures on electrodynamics. Um, Today we are going to discuss position, displacement, and separation vectors. Any point in 3 dimension in Cartesian coordinate can be expressed we have Cartesian coordinate x, y, and z, and any point here can be expressed x, y, z. We have origin, and this is our vector, and we called it the position vector, and unit vector is vector in this direction. Our unit vector. So R is called the position vector. And this is arbitrary. So R is x unit vector plus y unit vector plus z unit vector. And the magnitude of R is x square plus y square plus z square under root. And if we take the unit vector R, then the definition of the unit vector is vector divided by its magnitude. So it is unit vector, and it will become x unit vector plus y unit vector plus z unit vector divided by x square plus y square plus z square under root. And this again pointing radially outward. This R is pointing radially outward. R unit vector. If we have a small increment in R, say we want a small distance from here to here, say is a dr, and dr is infinitesimal displacement vector. So from x, y, z to x plus dx, y plus dy, and z plus dz. This is a small displacement vector, and we can express this vector dl dxx plus dy y plus dzz. And also sometimes we express as dr. This is when we have only one point into 3-dimensional space. We have a position vector, and we have a displacement vector if we need infinitesimal displacement or increment into that vector. But in electrodynamics, we encounter problems involving 2 points. Usually we have, this is origin, we have a distance from the source, origin to source, which is there is a source located here. This you can say there is a charge or a point charge or any charge, and we have a field point. So we want to measure the field at this point. We are not at the origin. In fact, we have one point where we are located a charge. This is a source point. And we have a point where we want to find the field or observe the effect. So this is called the field point. So we will, or this book will express our notation for field points, vector from origin to field point or observation point. And R prime for source location. This is vector from origin to source point. But in problems, we usually interested separation between the source point and the field point. So we need this vector. Source point to field point. And this is denoted by R, but this time symbol is used this R like this. So R is R minus R prime. Using head to tail rule, we can see this separation vector R. We are calling this R the separation vector from source point to field point. We can write unit vector or again vector divided by magnitude, and it turned out R vector R prime vector divided by R vector R prime magnitude. And in Cartesian coordinate, we can express our x minus x prime x unit vector plus y minus y prime y unit vector plus z minus z prime z unit vector. And the magnitude of R will become x minus x prime square plus y minus y prime square plus z minus z prime square. And our unit vector will be x minus x prime x unit vector plus y minus y prime y unit vector plus z minus z prime z unit vector. And the magnitude x minus x prime square plus y minus y prime square plus Z means Z prime square. So throughout this book we will maintain these notations. We will reserve R prime for source point. So it is the distance from origin to the source point, and R for field point, and or the separation vector between source and field point. And if we have a point at origin, say we have the source point at origin, then this is origin and we have a source point, say charge here. So we have, in fact, R prime is equal to 0. So the R vector will become just R. We will continue with the next section in next lecture. See you into next lecture.